Andrzej introduced me as Krzysztof, but I know that for English-speaking people, that's pretty much unpronounceable and difficult to spell, so I usually go by Chris. And I want to talk to you today about some mythical creatures. So, Hippie Dragons. Hippie Dragons is a phrase that you use when you have a map and you don't know what lies there. So you put Hippie Dragons, so people understand that you don't know that and you're supposed to explore. This is a phrase that is actually modern. The original phrase was "Here be lions," but of course, ancient map doesn't have dragons in them. However, there is one particular, not a map, but a globe, Hunt Lennox globe, that actually has this phrase written on it. There is a small inscription in Latin, "Hier sunt dracones," which means "Here be dragons." I want you guys to remember this for a second while I talk much about slightly more scary stuff, which are layoffs. Layoffs are the main topic for our industry for the last 2 years, I think. But with all the ends come new beginnings, which usually begin with recruitments. So we are very much prepared for recruitment interviews. And during those, you're supposed to ask questions about the project because you're supposed to show that you're interested. You actually care about those recruitments after so long of not caring because you had so many of them. So you ask questions. One of the good questions is, which Rails version do you guys use? Because you're interested in the project. If it's 7, that's cool. That is 6, then it's okay. If it's 5, there is a little, well, unease in the air. And if it's 4, you actually want to charge them extra. Some other questions is it DDD? Because that's a trendy thing, yeah? Do you use event sourcing? Yeah, yeah, you might actually want to take a pay hit when you actually get into a project like that. Or maybe you are front-end inclined and you want to get some info, whether you're using TypeScript or perhaps React. How do you manage state on the front end? Or maybe not. Maybe you're scared of front end and you want to look at the other side. You want to look at the process, the continuous integration, the continuous deployment. Perhaps if you're into Kubernetes or Nomad, that's also a good question. That's a valid question during a job interview. Some people will ask about tests, which are really good questions, to be honest. Perhaps mutation testing, which you guys didn't get to at the workshops. I think they didn't actually commence. Yeah. So these are all valid questions. But the other person usually gets the good answers until you ask them, can you tell me a little bit more about the database? Because you'll get answer like, oh, it's Postgres, and which version? I don't remember. I'll have to check. I'll get back to you with this. Yeah. Most of the real shop talk that we do in the hallway track, in interviews at work, are related to storing and manipulating data. And that's precisely what a database does. If you don't believe me, let's take a look at a typical Rails application. This is extremely simplified and wrong version of the diagram that shows you a Rails application, but it gets a point across because it can be divided into 3 sections. The first one is the front end, which is the part that usually the end user cares about because that's how you get customer support tickets. Something doesn't work, and you're supposed to figure out what actually doesn't work, but they look at the front end. Then there is the big part. The big part is big because we actually care about this. We are Ruby devs. We want to look at this part and this part only. This part is the interesting part. But there is a part that actually does most of the work, which is a database. And if you still don't believe me that this is the case, let's take a look at something called test pyramid. If you Google test pyramid, this is this idealized version how you're supposed to test. You're supposed to have most of your tests as a unit test. You're supposed to have some integration test for things that are not supposed to be tested in isolation, and a small layer of end-to-end test because these are expensive, these are difficult to maintain, and they are error-prone. If you Google the opposite of this, is ice cream cone, which has only a few unit tests, more integration tests, and then you have a lot of end-to-end tests. And if you really want the ice cream, these are the manual tests. But for the typical Rails app, none of those really apply. This is the idealized version, and this is the Rails version of things. We actually can test only a few things in unit tests. We sometimes have this layer of end-to-end tests because people like to automate browser for some reason, but majority of the tests are integration tests. The reason for them being integration tests is you integrate with the database. You're supposed to hit the database to actually check if the logic works right. Most Rails applications are pretty useless without a database because the applications are made as a point of interaction with the data storage, with a database. And we still treat those databases like some storage box, something that we're not supposed to really look at. These are exotic, these are weird. These are the dragons on the map. I'd like to talk to you about how to handle those mythical creatures. First of all, let's acknowledge databases are weird, like really weird. They are not object-oriented, they are not functional, they're declarative, which is a very, very foreign paradigm. Well, they are not aware of most of your abstractions, including the user's data separation, which means that, well, we connect only as one user to the database, and the database doesn't know who's logged in because it's only one user. The Rails know which user is it. But they have one redeeming quality. They are very, very good at processing data and much faster than Ruby. Okay, let's start with the smallest creature there is, SQLite. By the way, images generated by Midjourney. I asked it to generate a database as an animal. All right, so SQLite. Typical use for SQLite is, I've made this site during my free time as a project that I do after work, and I really want to show it to the world, but I don't feel like setting up a full database. It's not my thing. And if you look at the SQLite documentation, there is this long text about how to use them on websites. And yeah, you can actually use them for simple, wait, what? If you actually multiply those numbers, they're handling 20 million SQL queries in a day on a server that's in a VM, 7 years ago hardware, so not your latest thing, the crappy Skylake of the time. And they share this VM with 23 other applications. This is SQLite website. So turns out that the Clark Kent of SQLite is actually Superman. And yeah, SQLite is extremely, extremely fast. And it's a public domain. And it has very easy backups, which those things are like marketing ideas. But think about it this way. It can handle lots and lots of traffic with a free tier hosting. It can be embedded into a gem, and you don't really care if it's, well, the license won't work because it's public domain. And also, if you think that the backups are important, think about it this way. You create one set of fixtures on one set of tests, or even just a schema, and you copy this file 5 times, and you have 5 databases working for your tests, and you can run them in parallel, which is extremely fun. They have some downsides with those, like in typical implementation, every single query will lock Ruby. So you're supposed to use processes instead of threads. And because there is only one writer, you might get some database unavailable. So you're supposed to do retries when you insert data or update data. And there is no full text search, which is really handy for small websites because search is a popular feature. But there are ways around it. Yeah, so this very small database has lots of usages, and you might want to consider it even for a larger scale product that has lots of reads. There is also, of course, the elephant in the room. And this one is cool because it's probably the best open source project ever, at least in my opinion. It's extrememely versatile. You can replace all of your stack with just Postgres. Yes, all of it. If you read this post by Stefan Schmidt, I think this is amazing, CTO's blog. This was very popular some time ago. This lists the cases in which Postgres can replace some other part of your stack. It can be GraphQL, it can be a cache, it can be a queue, it can be mostly anything. Amazing article. It got really popular in Hacker News for some time. And I extracted some of the examples because I think they are cool. The one that really hit me was the unlocked table. This is basically cache. Unlocked means that it doesn't write write-ahead log to the disk, which means that if your database goes down or your tables are gone, like cache, but it's very, very fast compared to the normal storage, and it's still SQL. Rails actually supports this, starting version 6, I think. You can create unlocked tables straight from migrations. Really cool. But you think that, yeah, I already have Redis. What do I need this for? This is cool as a proof of concept, but it's pretty much useless. But instead do this. It's a thing you append to RSpec on tests. And if you use this, all of the tables that RSpec creates will be unlocked, which means they are much faster. I've tested in a couple test suites from different clients, and this managed to shave off like 3.5 minutes of tests and on a bad test suite, and about 20 seconds on the good, without any other changes. It works really good if you have lots of writes, so factory cascades and stuff. Really cool. But remember, if you restart your database, the tables are gone, so you have to do migrations again. Good for CI, maybe not so good in development. But holy shit, this is fast. This is really cool. There are the only other features that we can use. Like, have anyone actually browsed the features of Postgres? It's a really long document, but it's really fun. Like, there are interesting things in it. I'll skip to the advanced features section, because we like advanced features. And in my humble opinion, the most fun begins over here in window functions. Have anyone ever used a window function? Unfortunately. Okay, it's an interesting case. Window functions are basically per row calculations. So you get some results, but you want to apply some calculation for every row. They are context aware, so they are aware of other rows, and they can do lots of things. They are mostly misunderstood. People think of them as some exotic SQL that the data engineers and perhaps the data scientists will use in some other queries that you're supposed to do in reporting or business intelligence. But actually, they are freakishly powerful. Here are some examples I extracted from various different projects. And yeah, let's start with the first one, which is calculating some average. Originally, it was an employee salary average, but this one actually speaks better to you. In SQL, you basically do this over and give it some idea on how to apply the calculation for the particular row. So in this case, this will actually split this entire thing into salary per average salary of every department, because this is the partition. And yeah, this looks like SQL, and it looks like SQL that you're not used to, so you don't really like it. But you can write it in Rails, and it's perfectly reasonable. You can even put it into some kind of DTO or the kind of object, and you will get a perfectly object-oriented code out of this without just this tiny, tiny bit of SQL sprinkled over it. And this is much faster than doing this calculation in Rails with 2 queries and combining the data from the 2. Okay, second example. Cheapest product per category. This is useful for e-commerce stuff, like you want to upsell something cheap. Someone wants something expensive, so now everything looks cheap, so you sell them the thing in a particular category. Yeah, so this thing will assign a row number to every category and will order them by price and name. The name is important because now the ordering is stable, so you get the same products every single time. And yeah, you could do things like you can get all the cheapest items for categories and you want to combine them, and you can do it in Ruby, that's fun, but you wouldn't have this much fun without pattern matching, like functional programming and declarative programming, super cool. And yeah, you can still do it in Rails. Yeah, it's possible to do this thing in Rails, and it's perfectly fine, it works, it's wonderful, even the pattern matching thing works. Yeah, so the last item from the window functions I'd like to show you is one that is extremely Googled by everyone. The Stack Overflow answer has like thousands of votes, how to do the cumulative sum. So something, 1 month this, then month this, plus the previous month and the previous month, and you add something in a cumulative way. And I actually managed to refactor this into 2 different things, which is cool. We have some composition inside of SQL. It's not just one single big query, you can understand the parts. And what's even cooler is that, well, by the way, this sounds like in English, right? It's kind of confusing seeing this many keywords in a row. Yeah, I think this too, that's weird, but still, it's pretty cool. You can still do this in Rails, including composition. It works. You can just do 1 query and then do from that query, and you can do the window function, and it will actually do all rows between beginning of time to current row. Apply this to the sum. Really cool. And this is also really fast. All those queries are really, really fast compared to doing this thing in Ruby. And why? Let me explain. Explain is a feature that people are aware of, but they don't know how to read it. Like, raise your hand if you know what the first thing on the cost estimation actually means, because you have always from this to this. Yeah, some people know, but it's very, very, I would say, weirdly explained in Postgres documentation. It contains a hidden feature. Postgres actually keeps a table of statistics, and you can use it for various different things. Do you know if you use Gmail and you search for something, and you get page 1 of about 300 something, that about 300 something is actually a feature of explain function, which will try to estimate the number of rows for a query. And there is an explain method in active record, but it's kind of bad, and somebody can write the pull request. It will be really, really cool to accept other options, because there are options to explain. It's not just like explain and that's it. You don't have anything else. There are lots of different options that you can enable to get some more data out of it. Let's try a non-trivial but easy query, like just one join. There are 2 conditions, one of them in join, the other one is in where. Nothing too fancy. And one of the features that is available in explain are costs. I've disabled them explicitly to get the simplest format possible. And this is the explain for this query on a small table. Okay, how to read this thing? The things with arrows are strategies. You can look up each strategy. Sequential scan is just each in our term, so iterate over the entire thing. Hash is to build a hash. And sequential scan, so this loop, can have a filter, which will actually remove some elements out of it. And if you have a nested item, that means that the strategy is required for this one. So sequential scan is required for this hash to be built. So you have a list, well, not a list, a tree of strategies to apply. Okay, sounds simple. Let's turn on the default. Now you have some more data. And in this particular part, you have this estimation. I actually written a gem that extract this, so we can just do estimate count instead of count, and you get an estimate. I know there are some other gems that do this, but they require migrations, and mine doesn't. Plus is mine. Shameless plug. Okay, but let's go to the original topic, which is explain. How to read this thing. Okay, so the first one, which is really tricky for some people, is the cost to get the first row, because you have to remember that those strategies are actually streaming data, and they try to parallelize as much as possible. So this is the cost to get the first row out of this strategy. This is the cost of getting all rows from the strategy. This is the number of rows that we estimate to find. And this is the size in bytes of a particular row. Really cool. If you do limit 1, you will only get this cost, because basically we only care about the first item. If you don't do limit, you'll get this cost, because we need all items. All right, sounds simple. And you have to remember that the costs are, well, sometimes the query have to wait for something, because you basically need the strategy downwards to be completed before you can do something. So in this case, this hash gets written instantly from this sequential scan. All the sequential scans can start immediately, so the 0 is the cost for the first row, because you're basically iterating and you already got the first row the first time you iterate. But this hash join has to wait on this hash to be built to actually do something. So the strategies can block other strategies. Time to first row is important to know what is actually waiting for something to be done to start executing this strategy. Sounds difficult, but to be honest, it isn't. And you can always validate if this is actually the case by adding analyze to explain. Analyze would actually run a query, so you get the real time of how long something took. And if you want to do the explain analyze on insert or update or delete, run it in transaction and roll back. That's the thing that they don't mention in docs for some reason. I don't know why people like inserting tons of rows, because they don't understand that they can roll back after explaining something. All right, so you get some extra data. There is a second parenthesis. So in the second parenthesis, there is an actual time to first row, which is in milliseconds. Time for all rows, number of rows, and loops means that some strategies execute more than once, so you know how many times they executed. Okay, sounds simple. You also get the planning time, which is how long Postgres took to figure this out. The planning time are reused, so the second time we'll run it, it'll be lower. And yeah, you can actually tell that this is basically the real time for those costs. It's pretty accurate, but the actual time, there is some actual time that will take to get the first row because you have to read it from the disk and you have to apply this filter. So the cost isn't actually matching the actual time that closely. Okay, but these features are probably you have used, at least I know that people use explain analyze. The one that will be default soon is buffers. And buffers are important. That's why they will be default. I think in Postgres 16 or 17, they're still debating that. Buffers will tell you how much data was read from the disk and how much was actually in RAM already. So you can see how much of a disk access you need to have something to be used. And you get the memory usage for those. And you have this, just a second. I think I lost one slide. Yeah, I think I lost one slide. No, not to worry. If you rerun this, you'll see that the buffers change. And you'll get more hits. There are the hits in the buffer, then reads for the second time. And also the execution time will be lower because there is already some data in the buffers. How can you optimize it even further? Well, use an index. And indexing is like, I don't know, this is like magic to some people that will try to do every single index, or they try to figure out some magical way of trying which index will be good. There are many, many theories, but to be honest, there are some rules that you can actually apply. Like query can have only one index. It can be used for either sorting or filtering or both. But you can't use two different indices, one for filtering, one for sorting. So you want to take a look at order by and where. And the database decides which one to use based on which one seems to be the most beneficial. There is an app by Andrew Kane called PG Hero that has a very nice algorithm for finding missing indices. There are different types that you might want to try based on cardinality or type of data. And it's very good to monitor the usage of indexes, which you can find in Postgres manual how to do. After you run vacuum analyze, you'll be able to see which indexes aren't used. And if you're interested about how to find those indexes, this is the basic algorithm that they use. It's, I would say, very complete in most of the cases. Like there aren't many cases in typical the Postgres database on Rails apps that this wouldn't find the right index to do. There might be some examples, but I wouldn't count on them if you're not do them yourself, because this was actually updated 5 years ago. So pull requests are very welcome. There are some dark outs when it comes to indexes, like things that are non-obvious. If your users are from all around the world, try all the combinations of geodata on indices, because it seems like sometimes only the latitude is important, sometimes the only longitude is important, sometimes the order is important of those, because the users are sometimes sliced into continents, sometimes sliced into countries. It depends on what actually works. So try all of them and see which one will actually get picked. You can try partial indexes, which are very nice because you can limit the amount of data in index, which will make it much faster. The where part should mimic part of your where query. So if they match, the Postgres might pick this particular partial index instead of the full one. And of course, there is a hidden feature that I haven't seen in production yet for some reason. Like it's not that hidden, but I still think that people are missing it. You can include columns in your index that are not being used for filtering or sorting. They are just there, so you don't have to go to the database. So if you actually use the index and the columns which are not really important but still are being fetched, then you can do an index-only query. Like you don't get to hit the database at all. And Postgres is also fun when it comes to extensions. This is the part why it's so versatile. The most popular ones are probably Postgres. If you have like lots of geographical data used, Postgres at some point. Timescale for time series, also very popular. But the one that's underutilized is Citus. I never know how to spell it, and to pronounce it, and I have to look it up. And I should probably do it before this talk. They added tons of different features because it's not only one thing. They actually merged several different extensions into one. The most important, I think, are columnar storage, distributed tables, and parallel querying. Raise your hand if you know what's a columnar storage. Some people do. When database stored the data on the disk, it's stored in rows. So you can actually fetch the entire row each time. But you can also do it the opposite way, which is to store columns. So if your query has like lots and lots of data, but only a few columns, the columnar one is much, much faster, typical for analytical use, business intelligence and stuff. But also, because every single one of those columns is the same type, you can compress them and store them in chunks, which means you'll have like 10 times less the storage. Really, really cool for lots of reads and mostly multiple rows or aggregates. In Citus, there is some downside because Citus on columnar storage can't really update the data. It's append only, but still very useful for analytical components of your app. And yeah, the built-in compression is really cool. Like you have 40 terabytes table and now it's 4. So it fits on an NVMe, expensive one, but still NVMe, which means it's faster. Yeah, it's very easy to use. You just add using columnar and that's it. There is no other magic to it. And you can mix and match in a single query. You can use some tables called columnar, some tables row-based, and it will still work. Really cool. It's small and faster for operations, mix match, and the use case that I really like, I remember yesterday we had a talk about cold storage. You do cold storage with Columnar Database, but the last partition, the newest data, is in the row database. So yeah, this use case is really cool. Like the data that is old, it's compressed, it's fast to retrieve in bulk, but the new one is easy to find. Okay. And then distributed tables with multiple elephants. A few smaller servers are usually cheaper than the big one, especially in cloud. The cloud doesn't really scale vertically. It likes to scale horizontally. So you can distribute your load to multiple tables. You can base them on user location. And you can put the frequently used together data together, even if you copy it several times to different servers. You pick the distribution column, like for example, if you have a white labeled app or some SaaS, you take the customer ID. You have this column into every single table, so they get distributed by it. And you use it you don't use it in the tables that are shared, which will get copied to every single server. So the data is together. You mark the shared table as reference tables, so Postgres actually has some idea on what you're trying to do. And that's it. There's only one function to invoke, which is a table name and which column you want. And for the shared one, I don't have the shared one, but I have the collocate one, which will be try to fit this data together with the other one. So it knows that the store ID in this table is the same as the store ID in the other table. These are the features that you can actually use right now with just a simple installing extension and running single SQL. There's like nothing difficult to do here. But if you really want, we can talk about some future curriculum for fantastic beasts, which are the other databases, the ones that are more exotic, which requires you to ping your DevOps and get some approval. CockroachDB is the fun one. It basically does what the Citus does, but automatically. You want to have this sharding availability. You have to want to do multiple servers. You don't want to do it yourself like in Citus. And you're really worried that one of your data centers will go down, which is something that might happen in the modern world. Yeah, so it has auto-sharding, auto-data distributions with hotspot detection, which means it will actually try to redistribute data if it feels that it needs to. And it can be geographically aware. So if it knows that the users in America probably want to get the data from an American server and users in Europe want to get it from a European server, it will do that. The second exotic database that you probably, well, this one you actually used, MySQL. What? What? Really? It's like the default choice for PHP devs. It's ugly. And Oracle bought it. Like one rich asshole called Larry Ellison bought this thing. Weird. But MySQL has been growing a lot of time. And well, it's different now. Really, it is a lot of different thing. It's super fast. Even compared to Postgres, this is really, really, really fast. It can do in-memory tables, which Postgres can't do. Even if you do unlock tables, they will still be written sometimes to disk. And this will be entirely in memory, perfect for tests. And also, well, it used to be a joke. It's a serious alternative. Like Basecamp uses it probably right now, or Hey, maybe. I don't know which one of them, but one of them are using MySQL. It has. If I ask you about what's the difference between MySQL and Postgres, most people will tell you, well, one is the one that you choose because it's the right one, and the other one's the fast one, which you choose when somebody else actually picked it and you can't really change it. But the reason why it's so fast is it handles transactions differently. It makes a different assumption on how to insert the data. Okay, let's go through an example. This is Postgres, and this is a very controversial topic right now, because it used to be like this, that if you have TypeScript, you're happy, but on the other case, you're also happy. But because the AJ changed it, you're now unhappy. So Postgres will do, it will add a second row and mark this one as stale. So the older queries will actually get this one, but the new one will operate on this one. And you have two rows. You have to clean them up. In vacuum or something. Vacuum will clean up this thing, but until it does, this is actually taking space and time. MySQL works differently because it will just update this thing in table, and they create a second table in which you have the rollback as a segment, which means every single transaction that will try to use the old data will get the new data, but it will apply the rollback. And because most of the transactions actually commit pretty quickly, and most of the transactions don't really need this assumption that you might get a stale data, and most of them will resolve correctly. They won't be rolled back. This version is just faster. It also has all the niceties of Postgres. There is a JSON operators, window functions, full text search. It all just works now. So it's right now a valid choice for a database for your project. Then there is more exotic fish. Is the fish? I don't know, to be honest. It's something. This one came from Russia, and it was used for Yandex. They have a lot of marketing data. This is Columnar Database. The use case is my data team takes a coffee break every time they run something. But if I give them access to some cloud-based solution, they will just run the budget to the ground. And oh my God, this thing has pre-calculated aggregates and everything is like super fast. The term in Russian is, forgive me for my Russian, ClickHouse, yeah, Tarmizit? Somebody will correct me, I'm quite sure. Tarmazit, спасибо. Which means ClickHouse doesn't press brakes. This thing is definitely not the slowest part of your system. It doesn't slow down the other parts. The other parts are the ones that are slow. It has multitude of different table types, which will do pre-calculated aggregates, or automatically sum the rows, or will try to do some exotic kind of updates in place. Really, really cool. Also really long documentation. Cloudflare uses this to do like 6 million inserts a second or something like that, which is crazy. The ingestion rate on this is amazing. I highly recommend you read this article. They migrated from Postgres to this. Yeah, but this is an exotic database, and we can get even more exotic databases. But unfortunately, we're kind of running out of time. And NoSQL is still a topic, document database are a topic, graph database are a topic. So perhaps a part 2 is in order next year. if you really like it. But in the meantime, feel free to explore on your own the fantastic world of databases. Thank you.
Are there any questions?
Thank you for presentation. Yeah, it was really good to hear it. And I have the question because you didn't explain how to perceive the cost value. 100 is high value, or how to evaluate it? Because I tried to read it in documentation, but it's not so. I don't know. It's like story points for me.
It is. It is exactly story points. You can actually check out the Postgres configuration and see which operation has assigned which cost, but it's predetermined, and you can modify them if you really want. If you think that, oh, I think the sequential scan actually is more expensive for me because I have very crappy hard drive, then you assign it a higher value, and the plan will change. But by default, there are some defaults that are taken from various use cases, but they are exactly just story points. And it just tries to sum the story points for a particular part of the query. So you're right.
With the unlogged tables, you said they are effectively wiped out when the database is restarted. Can it also work when the connection is reset? Or is it?
I don't think its connection is reset, but I definitely know that if I restart the Docker, they will be gone. Okay. I know if the database will crash in any way, they will be gone. I haven't tested how far it goes, but for continuous integration usage, like you want to have the database written from scratch and you want to run all the tests and then you don't really care what happens after it, this is really good. But you have to append that if this is run on CI. On local, this is actually problematic because you download some changes, you run some migrations, and you're sometimes in this weird state that, have I restarted Docker? Have I restarted my computer? Was it restarted automatically? My tables are gone. I'm supposed to run the entire migration set again. Oh my God, I don't want to do this. Yeah.
Cool.
Okay, thank you, Chris.
Thank you very much.